What if that famous, terrifying silence of space wasn't silent at all? What if, right now, the universe wasn't a void, but a vast, unimaginably loud ocean of sound? Forget the Hollywood pew-pew of laser beams. We're talking about a reality where the fundamental laws of physics have shifted, where the vacuum of space is suddenly filled with a mysterious medium. Let's call it the etherium, an ultra-diffuse gas that allows vibrations to travel. If that flipped switch tomorrow, the first thing we'd experience wouldn't be a sound, but a feeling, a deep, pervasive, subsonic hum resonating through the very fabric of our planet, our ships, and our bones. This would be the cosmic background hum, the sonic echo of the Big Bang itself. For 13.8 billion years, the light from that event has stretched into the microwave spectrum, which we see as a static map on our telescopes. But the sound? That primordial shock wave would have been stretching and slowing down all this time, its frequency dropping into a register so low it's more a tectonic pressure than a noise. It would be a B-flat, but a B-flat 57 octaves below middle C, a note with the wavelength longer than the solar system. This wouldn't be something you hear with your ears, it's a vibration that will become the baseline of existence, a constant reminder that we are all living inside the fading fingerprint of creation. And layered atop this fundamental drone would be the rhythm section of the cosmos, pulsars. These spinning neutron stars, the ultra-dense corpses of exploded suns, are nature's most precise metronomes. We know them as blinking points of light, but in a sonic universe, each rotation would slam into the etherium, creating a powerful rhythmic shockwave. From thousands of light years away, we'd hear them not as flashes, but as clicks, pops, and steady beats. The galaxy would be alive with the celestial drumline, each pulsar keeping its own unique time, a Morse code of natural physics ticking with a precision greater than any atomic clock we could ever build. This constant interstellar rhythm would have fundamentally altered human history. Ancient navigators might have tuned to the beat of a specific pulsar instead of the stars, and our myths would be filled with tales of the great heartbeats in the sky. But the true monsters of this sonic cosmos would be the events so powerful they warp space-time itself. Black hole mergers. We've detected these cataclysms through gravitational wave observatories like LIGO, feeling the minuscule stretching of space-time as these unimaginably dense objects spiral into each other. In our new reality, that stretching would also stretch our etherium. The resulting sound would be the deepest note in the universe, a frequency 1,000,000 times lower than the human ear could perceive. If we could hear it, it would be a groaning, a cosmic cello string the size of a solar system being plucked, a shuddering thrum that resonates for days or weeks. This is the sound of pure mass screaming, the final death cry of a dance that began millions of years ago. Each merger would ring through the galaxy like a bell, and astrophysicists would be sonic seismologists, listening to the ringdown of these events to understand the properties of the black holes. But the violence isn't just in the extremes. Our own sun would be a constant raging inferno of noise. The nuclear fusion at its core would generate a deep, continuous roar, and the convection currents on its surface, bubbling plasma cells the size of continents, would create a cacophony of pops, sputters, and explosive bursts. Solar flares would sound like unimaginably massive tidal waves of fire crashing through the etherium, and the solar wind would be a constant hurricane-like scream emanating from our star in all directions. For an astronaut, even near Earth, the sound of the sun would be a permanent, overwhelming presence, requiring intense damping technology on suits and ships to prevent immediate hearing loss and psychological trauma. We wouldn't just see the sun, we would be acutely aware of its furious, energetic life.
Yet for all the violence, there would be sublime beauty in this new symphony. The stellar nurseries, the great nebulas we see as silent, beautiful clouds of gas and dust, would become celestial choirs. The fierce solar winds from newborn stars would buffet the surrounding gas clouds, exciting the etherium and causing them to resonate. Each nebula, based on its size, density, and elemental composition, would have its own unique chord. The Orion Nebula, a bustling stellar nursery, might resonate with a bright, hopeful major chord, a sound of creation and potential. The Crab Nebula, the remnant of a supernova observed in 1054, would have a darker, more complex and dissonant tone, a haunting minor key echoing its violent birth. We could literally listen to the life cycle of stars, from the harmonious beginnings in a nebula to the deep final groans of a black hole's formation. This would revolutionize astronomy. Instead of silent telescopes, we would have massive orbital listening arrays, vast parabolic dishes designed to tune in to the specific frequencies of distant objects. The field of acoustic spectroscopy, where scientists could determine the precise composition of a distant exoplanet's atmosphere not by the light that passes through it, but by the sound its winds make as they whip across alien landscapes and through strange chemical soups. We could hear the ring of a neutron star collision, the deep tidal flows on water worlds, and the constant low-frequency hum of a gas giant's immense atmospheric storms. The universe would become a dynamic, audible soundscape, telling us stories about physics and composition that light alone could never reveal. And this leads to the most profound and terrifying question of all. In a universe full of sound, would we be alone in listening? The search for extraterrestrial intelligence, SETI, would transform overnight. It would no longer just be about searching for a narrow-band radio signal or a deliberate laser pulse, patterns in the limited spectrum of light. It would be about searching for patterned sound, anomalies in the cosmic symphony, a beat that doesn't match a pulsar's perfect rhythm, a melodic sequence repeating in the radio emissions of a gas giant, a signature of organized, structured sound that clearly stands out against the natural chaos of the cosmos. This is the concept of sonic technosignatures, a Type 2 civilization on the Kardashev scale, one that harnesses the energy of its entire star, might create vibrations we could hear across interstellar space. The hum of a Dyson sphere under construction, the rhythmic pulse of massive energy transfers. If sound could travel, the universe wouldn't just be louder, it would be more transparent. A cosmic conversation might already be happening, not in carefully beamed messages, but in the background noise of a galaxy waiting for us to develop the ears to hear it. We might not hear a message meant for us, but we might overhear the leakage of an unimaginable civilization going about its business. This changes everything about our place in the universe. We are no longer just a silent, isolated audience looking at a silent movie. We are listeners in a grand cosmic concert hall, and every star, every nebula, every black hole is contributing to the performance. And in that immense, overwhelming symphony, the most precious sound of all might become the one we already have. The sound of a breeze on Earth, the crash of a wave, and the human voice. Our own tiny, fragile, and beautiful solo in a galaxy that has finally learned to sing. And the new science of acoustic astrophysics would allow us to explore that soundscape in new ways unimaginable.